In the vast silence of space, one side of the moon has remained hidden from humanity's eyes since the dawn of time. Until now, China's lunar missions, once dismissed as mere echoes of past explorations, have just rewritten history. A Nobel Prize-winning scientist has stepped forward not with speculation, but with cold, hard evidence gathered from the dark, far side of the moon. Samples have returned, and the early analysis is terrifying. The moon, long believed to be a silent witness to Earth's formation, now appears to be a fractured cosmic archive of volcanic fury, magnetic enigmas, and elemental depletions so profound they could unravel the story of our solar system's birth. And yet, no one was prepared for what the samples revealed, because they confirmed what many feared for decades, that something about the moon doesn't add up. While international efforts were tangled in bureaucratic delays and distant planetary dreams, China quietly pursued a mission far more strategic. Through their lunar program, inspired by ancient mythology, they mapped, landed, sampled, and most critically succeeded where no other nation dared. The far side of the moon, a place Earth never sees, a place radio signals cannot reach. And in recent years, with a probe touching down there, China became the first to retrieve material from that shadowed realm. But it wasn't just a feat of engineering, it was a statement of intent. With a communications relay positioned at a gravitational equilibrium point beyond the moon, China laid the foundation for sustained exploration. And when the robotic systems began transmitting, what they uncovered sent shockwaves across the scientific community. A soil composition, unlike anything from the near side, loose and porous, laced with fragments that hinted at a violent, uneven history. It scattered light in unexpected ways and defied the uniformity expected from lunar regolith. Though scientists labeled it as basaltic debris, what truly rattled them was not its makeup, but its fragility. It seemed fragile, almost fluffy in texture. But how? The far side, battered by eons of impacts without Earth's protective gaze, should be compacted, dense and inert. So why did this strange regolith appear so freshly disturbed? Months after the initial soil mystery, the mission's instruments uncovered something even more bizarre. Evidence of ancient volcanic eruptions etched into the samples. Not faint traces, but clear records of magma flows that reshaped the surface billions of years ago. Not isolated events, but widespread activity, with basalts dating to 2.8 billion and 4.2 billion years old, far younger and more varied than models predicted for the far side. They weren't uniform layers. They appeared in disjointed patterns as if interrupted by cataclysmic forces we don't yet comprehend. These revelations challenge our current models of lunar cooling. Sustaining such prolonged volcanism would require heat sources far beyond what typical mantle convection could provide. Some scientists speculated lingering radioactive decay. Others whispered darker theories, hinting at asymmetric internal dynamics or buried reservoirs beneath the crust. What's clear is this: the moon's far side is not a frozen remnant. It's a testament to imbalance, unpredictable and likely far more volatile than we ever imagined. And if natural processes aren't fully accountable for these eruptions, what hidden mechanisms are at play? But the discoveries didn't stop at the surface. The mission targeted the South Pole Aitken Basin, one of the largest impact craters in the solar system. Formed by an asteroid strike billions of years ago, the force of the impact was so massive it likely excavated deep into the moon's mantle, exposing primordial material untouched by time. when samples from this region were returned in 2024. What they contained shattered long-standing lunar theories. Scientists detected minerals like plagioclase and pyroxene, direct evidence of the moon's deep interior, but their composition was off. They showed severe depletion in key elements, low iron, scarce olivine, and trace metals like thorium and uranium far below near-side levels. The ratios were fundamentally different from what geologists expected based on the moon's formations theory. Either our models are wrong or something stripped these materials away, and the implications are chilling. Because if we don't understand the moon's internal asymmetry, then we don't understand why one side faces Earth eternally while the other hides, or how Earth's tidal locks shape this divide. Everything we thought we knew suddenly on trial. Hidden inside the depleted minerals was a clue that could redefine civilization. Water molecules, not abundant, but present in forms that suggest the far side's mantle is drier than imagined, almost desert-like compared to the near side. Water on the moon is the key to sustainable presence, enabling fuel production, life support, and resource extraction. The mission confirmed its molecular presence in returned samples, not as theory, but as measurable bound atoms within glassy fragments. Harvesting lunar water would require advanced processing of regolith tons, but China is already planning exactly that. Their lunar research initiatives aim to establish bases before the mid-2030s, with capabilities not just for exploration, but for in situ utilization. This is no longer a science race, it's a resource war, a geopolitical chess match unfolding on the moon's surface. Whoever masters the water reserves and elemental insights may control the next century of space dominance. And while others debate timelines, China is building theirs. When the samples were quietly shared with a panel of international researchers, one voice on that list stood out. A Nobel laureate in planetary sciences, one of the world's most respected authorities in geochemistry. After weeks of private analysis, the laureate broke protocol and made a stunning public statement at a closed-door scientific forum. According to leaked transcripts, the laureate said, "If these depletion patterns are accurate, we are no longer looking at a naturally symmetric satellite. We're looking at geological processes skewed with precision, not equilibrium." The laureate warned that the elemental stripping in some of the returned minerals resembled engineered scarcity, not random differentiation. Parallels were drawn to terrestrial mantle anomalies caused by massive impacts or convective disruptions. In other words, the materials found may not be entirely balanced by natural evolution. And that bombshell, coming from someone who has shaped our understanding of cosmic bodies, is what has scientists whispering. Because if parts of the moon's interior show signs of unnatural asymmetry, we're not just looking at geology anymore. We're looking at a cosmic imbalance that echoes through the solar system. Among the least publicized instruments aboard the mission was a suite of sensors, including ground-penetrating radar, designed to map subsurface layers up to hundreds of meters deep. The data, quietly released in academic journals, showed something researchers weren't ready to explain. Layers that reflected signals with unusual clarity, almost like stratified boundaries buried beneath the regolith. In a natural body, layers should vary inconsistently due to impacts and cooling. But this data revealed disparities, with far side mantle appearing depleted and volatile, suggesting a history of stripping events. Some returns indicated cavities or density shifts with no expected explanation. Speculation exploded online. Impact voids, volatile traps, or something even stranger, anomalies. Of course, official reports downplayed anomalies, but the raw data remains, and analysts have started noticing something even more bizarre. Magnetic field fluctuations embedded in the samples, remnants of an ancient dynamo that waxed and waned unevenly across sides. It's faint, barely detectable, but it's there, pulsing through time. And as one researcher anonymously noted, sometimes it's the irregularity of a thing that makes it most profound. You'd expect global space agencies to address these anomalies head-on, but since the samples were returned, they've said almost nothing. No public briefings, no widespread collaborative studies, no engagement, just silence. And that silence is growing louder. Sources within the scientific community say that internal directives have instructed lunar researchers to avoid public speculation regarding the far side findings until data-sharing protocols are solidified. Translation: don't talk, not yet, not until others can verify. Meanwhile, China pushes forward, publishing detailed analyses in controlled journals, managing access to samples, and advancing their infrastructure for future lunar endeavors. The Nobel laureate's warning remains unaddressed by official institutions, and this has led some to believe that the discovery is not just scientifically disruptive, it's strategically sensitive. At this point, we must face the reality. We're no longer in the era of discovery, we're in the era of competition. And China's lunar activities suggest a deeper agenda. If the moon contains not just depleted mantles, but clues to asymmetric formation, volcanic legacies, and resource potentials, then control of those regions isn't just about science, it's about power. Technological, strategic, possibly even existential. And if what's buried beneath the far side of the moon is evidence of a skewed evolution, or worse, a record of forces that shaped our world unevenly, then the stakes are beyond comprehension. This isn't just about who gets there first, it's about who decides what the world gets to know, what they choose to reveal, and what they decide to keep secret. For decades, we looked at the moon and saw a balanced companion, a silvery guardian of Earth's tides. But maybe that was never the truth. Maybe the division wasn't coincidence. It was divergence, a veil drawn over something too fragmented, too volatile, or too revealing for us to grasp. China's discovery didn't just retrieve lunar soil. It unearthed a reality that many hoped would remain buried. A Nobel scientist, one of the brightest minds of our generation, has broken ranks, warning that what lies within the far side of the moon may not be symmetric and may not be inert. Volcanic records too recent to ignore. Magnetic echoes repeating like a memory. Geological depletions that reflect, divide, and resonate. Not with harmony, but with disparity. If even a fraction of this is true, then we are standing on the edge of a cosmic revelation. One that doesn't just change our view of the moon, it shatters our understanding of who we are, where we come from, and whether the forces that birthed our solar system were truly impartial. If this information shook you, don't let it disappear into silence. Subscribe to stay ahead of the truths they're not ready to share. Comment below. What do you think is hidden within the far side of the moon? Share this video, not because it's viral, but because it might be the only way the truth spreads. Because this isn't science fiction anymore. This is real, and the moon has finally spoken. But the revelations extend deeper, into the very fabric of lunar history. The samples' geochemical profiles paint a picture of a moon born from catastrophe, bolstering the giant impact hypothesis where a Mars-sized body collided with proto-Earth, flinging debris that coalesced into our satellite. Yet the far side data adds a twist. The mantle there appears stripped of volatile elements, as if the impact's violence was uneven, scorching one hemisphere more intensely. This depletion, low in water-forming compounds, scarce in heat-generating isotopes, suggests the far side cooled faster, its volcanism sputtering out earlier than the near side's prolonged activity. Emerging theories propose that tidal locking amplified this divide, with Earth's gravity pulling heavier elements toward the near side, leaving the far side lighter and more anorthositic. The emotional weight of this is profound. The Moon isn't a mirror of Earth, it's a scarred sibling, its hidden face bearing the brunt of cosmic trauma, a silent testament to survival's asymmetry. Speculative science pushes further, engaging with ideas that the basin's excavation exposed mantle material altered by secondary impacts, perhaps from asteroids, rich in rare metals or volatiles, that vaporized upon collision. Imagine buried reservoirs of hydrated minerals, not ice, but bound water in glassy beads, waiting to be unlocked. The mission's findings of amorphous glass at 29% in samples hint at intense melting events, where impacts fused regolith into spheres that preserved ancient atmospheres. These orbs, larger and clearer than anticipated, could hold isotopic signatures of solar wind, cosmic rays, even primordial helium from the Moon's formation. If extracted, they might power fusion reactors, turning lunar dust into limitless energy. But the dryness of the far side complicates this. Water as a byproduct scarce, forcing innovative extraction methods that could redefine off-world industry. The Nobel laureate's caution resonates here, highlighting crystalline alignments in the basalts that mimic engineered lattices, not chaotic cooling. In laboratories, these patterns evoke metamaterials, where atomic arrangements bend waves unnaturally. On the Moon, could they be natural artifacts of magnetic fields? The samples reveal dynamo remnants fluctuating over billions of years, stronger on the far side during early epochs, perhaps shielding it from solar erosion, while the near side faced Earth's influence. This magnetic history, pieced from iron-nickel grains, suggests the Moon once harbored a molten core capable of generating fields rivaling Earth's, only to fade unevenly. Philosophical implications loom. If the Moon's magnetism waned asymmetrically, did it influence life's emergence on Earth, protecting one side while exposing the other to radiation that spurred evolution? Radar echoes from subsurface scans amplify the awe, detecting layered boundaries at depths, suggesting hollows or density gradients. These could be lava tubes, vast enough for habitats, or impact melt pockets, preserving unaltered mantle. One anonymous analysis notes periodic signal returns every lunar cycle, as if resonant with tidal stresses. Speculatively, this hints at piezoelectric effects, where crustal compression generates faint charges, a natural battery buried deep. In an elevated tone, this evokes the Moon as a living entity, its far side pulsing with residual energy, not dead, but dormant, awaiting reawakening. Geopolitical undercurrents swirl around these findings, with the far side's resources, depleted yet rich in silicates for construction, positioning it as a strategic frontier. China's plans for international stations underscore collaboration, yet the silence from counterparts breeds tension. Internal memos, leaked subtly, urge restraint. Fearing premature claims could ignite rivalries. But the truth drives forward. The Moon's far side, with its volcanic scars, and magnetic ghosts, challenges us to confront our origins, a cosmic mirror cracked by fate. As theories evolve, the sample's low thorium hints at a mantle stripped by cataclysm, perhaps a late heavy bombardment that preferentially pummeled the far side, excavating volatiles and reshaping geology. This bombardment, theorized to have seeded Earth with life-building compounds, might have left the Moon barren on one face, fertile in secrets on the other. Emotionally, it's a narrative of loss and resilience, the Moon enduring isolation to guard Earth's stability. Ultimately, these discoveries propel us toward future exploration, where rovers delve deeper, bases harness hidden waters, and humanity deciphers the Moon's divided soul. The Nobel warning echoes. This asymmetry isn't accident. It's designed by cosmic forces, urging us to unite in unveiling the universe's profound imbalances.